even functions, they are symmetric to the y-axis. All right, the reason I'm giving you that as part of the definition for even is because Math Excel is going to give you some graphs. All right, and then they're going to say, okay, is the picture of this function an even function or an odd function or neither? So all you have to do is look at it. If you look at it and it's symmetric to the y-axis, then it's even. All right, so think butterfly, symmetric to the y-axis would be a nice little butterfly picture. All right, so that's why that part of the definition. Now, second part of the definition is f of negative x is equal to f of x. All right, this is good old-fashioned function notation. Now, the only thing that you have to actually memorize is this part on the left-hand side. So I'm going to highlight that. F of negative x. When we algebraically determine whether or not a function is even or odd, we're going to do f of negative x for our even. We're going to work that out algebraically, okay? So that's the part you memorize. All right, now two things for odd functions. Odd functions are symmetric to the origin. All right, and if you are going to try to memorize that, an easy way to memorize that is an odd function starts with O, and origin starts with O also, so that's an easy way to memorize it, okay? So again, when Math Excel gives you a graph or a picture of the function, you just have to look at it. Is it symmetric to the y-axis? Is it symmetric to the origin? Or is it not symmetric at all? Okay, if there's no symmetry in it whatsoever, or it's symmetric to the x-axis, then that would be a neither. It's neither even nor odd. For an algebraic process, the formula is f of negative x is equal to negative f of x. All right, there again though, the way the process, the algebraic process I'm going to show you, you only have to memorize the second part of that. All right, now when we do this algebraically, the examples that we're about ready to do here are going to be from an algebraic standpoint, because I'm assuming that if they give you a picture, you can look and determine whether it's symmetric to the y-axis or symmetric to the origin, so I think those are easy. We'll do the algebraic ones. We will always test to see if a function is even first, and then we'll get a yes or a no. If we get a yes, we're done, the function's even. If we get a no, then we will test to see if it is odd. If we get a yes, at that point, then it's odd. If we get a no, we've gotten a no and a no, then we'll know it's neither. Okay? All right, so there's your rules. Let's work out some examples here. All right, so for our first one, let's suppose they give you the function f of x is equal to a negative 3 x to the third plus a 2x. All right, and the question is this function even, odd, or neither? Okay? Now, you're always going to test for even first. So I generally write down the word even so that I remember I'm testing for even. All right, and the part that I highlighted in the formula was an f of negative x. Okay, now we do function notation. We did that just like last week. This tells you to take negative x and plug it into the function. You plug it into the function every place that there is an x. So I've got two places that I have to plug it in. So I'm going to have the negative 3. I'm going to replace this x with a negative x, and then raise it to the third power. And it's important that it is a set of parentheses around that, because that's the entire base. All right, plus the 2. Now I'm going to plug it in here, negative x right there. So that first step is nothing more than plugging it in. Now, next line, you have to algebraically simplify this. I'm going to start with this negative x to the third power. There's a little imaginary negative 1 sitting right there, right? Negative 1 to the third power. It's an odd. A negative number raised to the odd exponent is going to make it even or odd? Odd. All right, so then I've got a negative 1 times the negative 3 that's in front. Negative times negative makes it a positive. So I'm going to have a positive, and then x to the third is just x to the third. Okay, so you can do that simplification in your head. All right, now a negative times a positive right there makes the overall thing negative. So then this becomes a minus 2x. All right, now when you get to that, that's all there is to it. You take this answer and you ask yourself, does it match that original function? So you just literally go through piece by piece and see if it matches. All right, so right off the bat, does it match? No, because the original function had a negative 3x to the third. This has a 3x to the third. So the answer is no. So what that tells me is this is not an even function. Okay, so not an even function. That's okay. Now what I'm going to do is I'm going to go through and I'm going to test for odd. Okay, so of the highlighted part of the odd formula, that was the negative f of x. So negative f of x. That basically right there just says negative 1 times the function. So that's the math that we're going to do. So I'm going to take a negative 1. I'm literally going to put the 1 in there so that I can see it. And then I'm going to multiply it by that original function. Negative 3x to the third, and then plus the 2x. All right, now when we multiply by a negative, well, go through, change the signs, distribute the negative 1, just about any way that you want to look at that. Negative times negative gives me a positive 3x to the third. Negative times that 2x gives me a minus 2x. So now you've simplified it. So now, once you simplify it, you take this answer and you ask yourself, does it match my previous answer? All right, so does it match? So you go through, you check your terms. Both of them have a 3x squared, then a minus, and then a 2x. So the answer is yes. So that now tells me that this overall function is an odd function. So this is your process. You are always going to test for even, and you're always going to use f of negative x. Then you ask yourself if it matches the original function. Then you're going to test for odd. You're always going to do negative f of x, simplify, and ask yourself if it matches the other one. If I would have got a yes on the first one, I would have been done. It would have been an even function. But if you get a no, you got to keep going and you get a yes. Okay? Now, could I get a no and a no? I could get a no and a no. No, it's not even. No, it's not odd. All right, let's do one more example. All right, let's suppose we had the function f of x, and that's going to be equal to maybe say an x to the fifth plus an x squared plus a 1. Okay, so again, the question is it an even function, is it an odd function, or is it neither? All right, so we're always going to test for even first. So identify that you are doing even. The part of the formula that you have to have memorized for even is f of negative x. So that's always the part of the formula you're going to do. This says to take a negative x and plug it into the function every place that there is an x. So negative x in for that x to the fifth. Put the set of parentheses around that base, because the whole thing is being raised to the fifth power, plus a negative x, plug it in for the next x to the second power, and then a plus 1. All right, and then just like we did on that first one, if you have an odd exponent and you've got a negative base, we know it makes it negative. If I have an even exponent with a negative base, it makes it positive. Okay, so you can do the math really easy, because especially if there's no coefficient. So a negative 1 to the fifth power is going to give me a negative 1. So a negative x to the fifth. Negative 1 squared is going to make it a positive. So this term is going to turn into a positive term. So positive x squared. And then the plus 1 we don't do anything with. Okay, once you have simplified, you look at that entire answer and you ask yourself, does it match that original function? All right, and then going through looking at these, right off the bat, you can see that the first terms don't match. So then the answer is no. So we know the function is not even. Okay, now you got to test for odd. Second part of that formula is a negative f of x. So actually testing for the odd is the easy one. You just take negative 1 times the function. I generally put the negative 1 down first. All right, then put the original function, x to the fifth plus x squared plus 1. All right, think of it any way you want. You can distribute the negative 1. You can go through and change all the signs. It becomes a negative x to the fifth, a negative x squared, and a negative 1. Once you've gone all the way through, you take that answer and you ask yourself doesn't match the previous answer that you got. All right, and again, this one, pretty obvious, the answer is no. All right, the first term matched, but the second one did not, and the third term did not match, so it's a no. Since I got no and no, then the answer to this one is the function is neither. And usually that's the only thing you have to write. You either have to write even, odd, or neither. So if you get two no's, it's neither. You get a yes right off the bat on that first one, then it's even, you're done, you don't have to do any more. If you get a no on the first one, you do have to test for odd.